Next term, primitive unit cells, non-primitive unit cells. Primitive unit cells, they contains only corner points. Okay. So 8 corners having 8 lattice points. These are called corner points. So number of corner points are 8. Okay. So this is the unit cell present in a space lattice. Okay. So this type of unit cells, many unit cell, they are repeat in a 3-dimensional space. So each corner point that is shared by 8 other unit cells. Okay. So this corner point is linked with it is shared by 8 other unit cells. So that's why each corner point, so it is shared by 8 unit cell. That's why it only 1/8 part of it belongs to this particular unit cell. Okay. So each corner point is shared by 8 other unit cells. So one unit cell, its contribution of that corner point is only 1/8 part of it. So that's why each corner point per unit cell, that is equal to 8 into 1/8. So that is equal to 1. So out of 8 corner points, only one corner point that is totally belongs to a particular unit cell. Even though it contains 8 corner points, but each and every corner point that is shared by 8 other unit cells. So 1/8 part of this corner point and 1/8 part of this corner point, like that total 1/8 into 8 corner points. So only one corner point that belongs to a particular unit cell. So in primitive unit cell, which is also called a simple cubic unit cell, number of corner points are 8 and number of lattice points per unit cell is equal to only 1 point. Okay, 8 into 1/8. Why? Because each and every corner point that gets shared by 8 other unit cells. Next, coming to non-primitive or centered unit cells. So this type of unit cells, along the corner points, lattice points are also present at the center. Okay. So basing upon that, these are classified into 3 types again. Okay. So face centered unit cells, body centered unit cells, end centered unit cells. So first coming to face centered unit cells. So this is the face centered unit cell having 8 corner points. So this is common for all unit cells. So 8 corner points are there. Okay. And 6 points at the faces. So unit cell 3-dimensional, it is in 3-dimensional manner. So this 3-dimensional cube having 6 faces in it, and at the center of each face a point is there. So this is called face centered point. So totally 6 face centered points are there. Okay. So you already know about corner points. Number of corner points are 8, but actually only one corner point belongs to that particular unit cell. Why? Because each and every corner point is shared by 8 other unit cells. That's why only one point belongs to this. Then coming to face centered points, totally 6 points are there. Each face centered point that is shared by 2 other unit cells. That's why only half of the face centered point belongs to a particular unit cell. So totally 6 face centered points are there, and each point that gets shared by 2 unit cells. That's why 6 into half, that is equal to 3. So only 3 face centered points belongs to a particular unit cells. Okay. So number of corner points are 8 and number of corner points per unit cell is 1/8 into 8. That's why only one corner point. And number of face centered points are 6 and number of face centered points per unit cell. So that is equal to half into 6. Okay. Why? Because each face centered point is shared by 2 other unit cells. So half into 6, that is equal to 3. So total number of points per unit cell in FCC, face centered unit cell, so that is 1 plus 3. Okay. So that is equal to 4. So totally 4 lattice points per unit cell are there. Then coming to body centered unit cell. So this is the body centered unit cell. It also contains 8 corner points, that is common for all. Okay, and extra to this, it contains a point at the center of its body. Okay, so this is the body centered point. So number of corner points are 8, and number of corner points per unit cell is 1 by 8 into 8. So only 1 point. And body centered point that belongs to that particular unit cell only. No sharing of body centered point. So this is totally belongs to this unit cell. So that's why number of body centered point is 1 only. Okay, and total number of points present per unit cell is 1 plus 1, that is equal to 2. So total number of points are 2. Then coming to end-centered unit cell. So this is end-centered unit cell. It also contains 8 corner points. Okay, 8 points at the corners and 2 points at end. So this is starting and this is ending. So these 2 points are present at the ends. These are nothing but face-centered points. That's why end-centered point is also get shared by 2 other unit cells. I have already told now. That is face-centered point that gets shared by 2 other unit cells. So same thing here happens. So each end-centered point is shared by 2 other unit cells. That's why only half of it belongs to that particular unit cell. So totally 2 end-centered points are there. So 2 into half, 1 end-centered point belongs to that particular unit cell. So number of corner points are 8. And number of corner points per unit cell is 1 by 8 into 8, that is 1. And number of end-centered points are 2, but each point that gets shared by 2 other unit cells. That's why number of end-centered points per unit cell is 2 into half, that is equal to 1. Then finally, total number of lattice points per unit cell in end-centered unit cell is 1 plus 1, that is equal to 2. Okay? So all this about unit cell. Next coming to coordination number. So coordination number is, that is number of atoms or ions which are present around a particular atom or ion. Okay. So number of atoms or ions. So number of nearest neighboring atoms or ions present around a particular atom or ion. That is called as coordination number. Okay. So number of atoms or ions present around a particular atom or ion is called coordination number. For example, coordination number of NaCl. Coordination number of NaCl, that is 6. Coordination number of cesium chloride is 8. Okay. So coordination number of NaCl, each sodium ion gets surrounded by 6 chloride ion. So 6. Cesium chloride is 8. Each cesium ion gets surrounded by 8 chloride ions. That's why 8. Okay. Then coordination number of silicon in SiO2, that is 4. Then coordination number of metals, that is in between 8 to 12. Okay. Next concept, radius ratio. So radius ratio, this is ratio between radius of cation and radius of anion. Okay. So ratio between radius of cation and radius of anion, that is called radius ratio. So from radius ratio we can predict the coordination number. So this is used to predict coordination number.